Hello everyone. Imagine that you want to open this door. So what you will do, you will grab this handle and you will apply a force like this. So the door will open. It will turn like this and it will open. But have you ever wondered that why the handle is provided here only? It is not provided in the middle of the door. It is not provided at the end of the door. It is provided on this side only, at this end of the door only. So to understand that, we have to first understand a small concept. Let us suppose that you have a rod and you have fixed a rod at this end. So you can say that you have pivoted the rod. You have pivoted the rod at this end. Now, if you apply a force in this direction, what you will notice is that this rod will start turning like this, turning in this direction, like this. So, this effect of force, this turning effect of force, this turning effect of force is also known as torque. We can name it another way as well. We can say it is moment of force. Now the magnitude of this torque is given by torque equals to force multiplied by perpendicular distance. This means whatever your magnitude of force is, it can be anything it depends upon your capability. It can be 2 newtons. If you are very muscular, it can also be 10 to 15 newtons. So the magnitude of force that multiplied by whatever the distance, perpendicular distance from your pivot point is. So this means, let's say if this is your line of force, because you're applying a force in this direction, so this becomes your line of force. From this line of force, whatever the distance, perpendicular distance is, this much distance, this is called perpendicular distance. So the product of force multiplied by the perpendicular distance, this gives me the magnitude of torque. Now let us come back to our door. What you can see is this door is pivoted from these two hinges. So this entire frame of the door is fixed in this line. And if you see the handle of the door, you can see that it is located as far as possible from the fixed line. From the formula, you can see that if the perpendicular distance becomes high, the torque will also become high. So that means if the handle is located as far as possible from the fixed line, it will produce a greater turning effect. Greater turning effect. So that's why the handle is provided as far as possible from the pivot point. Let us understand this with the help of an example. So this says that a girl applies a force of 20 Newton at a distance of 0.5 meter from the hinge of a door. So it says that the distance from the hinge of the door to this, it is 0.5 meter, and the force applied by the girl is 20 Newton. So the force is 20 Newton. F is equal to 20 Newton. I want to calculate what is the torque which is applied by the girl. So it can be given by F into D. We just saw the formula. So it will be equal to 20 multiplied by 0.5. So this gives me 10 Newton meter. How does this Newton meter come? We know that the unit of force is Newton and the unit of distance is meter. So the unit of torque becomes Newton meter. And in case you wonder what does this symbol means, so this symbol is tau. Let us try one more example. But before watching the solution, what I want you to do is I want you to pause the video and think about this and then see the solution. What does it say? A spanner of length 30 centimeter is used to turn a nut with a force of 40 Newton. Calculate the torque. First of all, let us identify where is the pivot point. If you see, the spanner is fixed at this point, the nut. Along it, it is rotating like this. So I can consider this as my pivot point. Now the force which is applied, it is equal to 40 Newton. I want to calculate torque. So torque, again, it is equal to F into D. So that will be equal to 40 multiplied by. Now, what is the perpendicular distance? It is given that length of the spanner is 30 centimeter. If you see from the pivot point to the end of the spanner, it is nothing but the perpendicular distance from force to pivot point. So I can say that the length of the spanner is equal to this perpendicular distance. So that is equal to 30 centimeter. And 30 centimeter, I have to convert it into meter because I am using SI system. Newton is SI system. So I will write it as 0.3 meter. So this gives me 12 Newton meter of torque. Now imagine that you have two rods. You want to rotate first rod in clockwise direction. The rod is pivoted at this point and you want to rotate this in clockwise direction. So that means you want to rotate it like this in this direction. Where will you apply your force? Pause the video and think. You will apply the force in this direction so that it will make this rod rotate like this. Again, if you want to rotate this rod in anti-clockwise direction, anti-clockwise direction means this direction, opposite direction like this. So if your pivot point, if your rod is pivoted at this point, where will you apply the force? You will apply the force in this direction. So this will rotate the rod like this. We use specific sign conventions to define clockwise rotation and anti-clockwise rotation. So for clockwise rotation, we take the sign of torque as negative, and for anti-clockwise rotation, we take the sign as positive. This is just a convention which the people have decided. There is no hard and fast rule that why we have taken clockwise as negative and anti-clockwise as positive. But for our convention and for uniformity all over the world, we take clockwise to be negative and anti-clockwise to be positive. Now imagine that there are two people, two person. This is person one and this is person two. They both are sitting on a seesaw. The weight of the person one will act in this direction and the weight of the person two, it will act in this direction. Now you think whether the person one, the weight of the person one, he or she will bring clockwise movement or anti-clockwise movement. Pause the video and think. So what you can see here is the person one, as the pivot point is here, he will bring the torque or the turning effect in this direction like this. So that means he's bringing anti-clockwise torque. And similarly, if you see person 2, what you will notice is that he is bringing torque in clockwise direction like this. Now, when will this system be in equilibrium? That means when will they exactly balance out each other? When clockwise moment or clockwise torque is equal to anti-clockwise torque, then they will balance out each other. So this condition, when both of them balance out each other, it is called equilibrium. Or if I want to be more specific, it is called stable equilibrium. Stable equilibrium means the whole system which is given here, it is at rest. They perfectly balance out each other, and they are at rest. We also say that the condition for stable equilibrium is the algebraic sum of the torque should be equal to zero. What does this mean? Just now we have seen that the clockwise torque is taken as negative and anti-clockwise torque is taken as positive. So let's come back here again. Let us suppose that this person who is bringing anti-clockwise torque, he is bringing, let's say, 30 Newton meter of torque. And the second person who is bringing clockwise torque, he is bringing minus 30 Newton meter of torque according to sign convention. Now, what will be the algebraic sum of clockwise and anti-clockwise torques? It will be plus 30 and minus 30. That will be equal to 0. So I can define stable equilibrium in another way. What I can say is that the algebraic sum of torques, that should be equal to 0. Then I can say that the system is in equilibrium.